Yes, good evening student. Today we will discuss about week 10 assignment, and we will also discuss concepts which are discussed in lectures of week 10. Okay, you can also ask for your doubts. We will start after 2 to 3 minutes. Okay, we have to wait for some time to join other student, then we will start. Okay, we should start now. First of all, if you have any doubt, you can ask in the starting of class from the lecture. Okay, you can write me in text box, or you can unmute yourself and you can ask. Okay, first of all, okay, so we are going to start assignment. I think some doubt is there. Check. Okay, so this is assignment number 10 of previous semester, which is completed before that. Okay, so first question number 1. The incorrect statement among the following is. Okay, so we need to find out incorrect statement. First is, glass electrode is ion selective electrode. Yes, it is true, because glass electrode is nothing, it is made of glass membrane, okay, which is ion selective. Okay, inside this glass layer there is one solution, particular concentration of hydrogen ion. Okay, and outer that this is analyte, which also has some concentration which is unknown. So what we do, and it is connected by some AgAgCl and what. Okay, So what will happen here? It will compare concentration in analyte and concentration of respective hydrogen, respective concentration which is filled in this pH or glass electrode. Okay, so generally it is known as pH electrode. Okay, this working principle is followed by pH electrode. Okay, so on the basis of concentration difference of proton, hydrogen ion or proton, we can say. Okay, so according to concentration difference, it will give some potential which will be used for pH determination, or sometimes it can be also used for other ion determination also. Okay, so glass electrode is ion selective electrode. Okay, so this membrane, it is also known as glass membrane, which is responsible for some specific ion selection. Okay, so first statement is correct. Then glass electrode consist of thin film pH sensitive glass membrane. Okay, I have already explained this thing. This glass electrode has this thin layer of glass which is glass pH sensitive glass membrane. Okay, pH sensitive. Okay, so what is meaning of this sentence means it will give signal if pH is changed, inner side and outer side. Okay, so it will compare this solution. Okay, one is standard solution which is inside in this pH cell, and another is outside analyte which is your sample or your analyte, you can say. Okay, so this statement is also right. Then statement C is, for glass electrode the activity of proton inside the membrane is constant. Yes. Okay, because this inner solution concentration remains always constant because it is pegged. Okay, and the concentration inside this potential is proton is constant. Okay, and what is the work of this electrode? It is just compare the concentration of analyte. Okay, so this statement is also right. Okay, so we can say, so all statements are correct. Okay, so incorrect is none of them is a incorrect statement. Okay, so obviously D is the right answer. Any doubt here in this question? Okay, let me read some brief statement. It is selective. No, it is not only for hydrogen ion. Okay, some other ion also can be measured, like sodium ion. Okay, and some monovalent ion can be also measured. Okay. So our second question is, yeah, it is written here. This is the explanation of this question. A glass electrode is type of ion selective electrode made of doped glass membrane. Okay, this glass membrane, this is not simple glass membrane. Okay, it is doped by some metals, I think, like that. Okay, so it is doped glass membrane that is made of thin pH sensitive glass membrane. Okay, it is known as thin pH sensitive glass membrane. Sorry. For glass electrode, the activity of proton inside the membrane. Okay, inside the membrane, suppose it is A1, it is constant, it will remain constant. Okay, hence all the statements are correct. Okay, so inside the membrane concentration is constant, and it will, this is the only case where it will we will able to find out the concentration or activity of hydrogen ion in analyte. Okay, so this is, yes, what happened? Please mute yourself. Please mute yourself, your mic, while the class. Okay. If you want to ask, then your background should be clear. Okay. No background noise should be there. Otherwise, all students will be disturbed and it will be not good. Okay. Second question is, the active component of zone, it is not reductor, it is reducer. Okay, so what Jones reducer do generally, it is a zinc amalgam. Okay, zinc amalgam means it is a mixture of zinc and mercury. So if you will add this reducer in your analyte, zinc will be oxidized. Okay, zinc will be oxidized, Zn plus 2 plus 2 electron. Okay, so it will be act as a reducer. It itself is oxidizing. Okay, but it will provide 2 electron. So these 2 electron will consume to, suppose this is some species which is already oxidized which is in a positive charge, so it will be reduced. Okay, so we can say 2R. Okay, so zinc is oxidized and it will give 2 electron. These 2 electron will be consumed to reduce some other species. Okay, that's why it is known as reducing agent, and this is a special name is given, which is John reducer. Okay, so it is nothing but zinc amalgam, mixture of zinc and mercury. Okay, so it is written here John reducer. Reducer is a device used in to reduce aqueous solution of metal ion. Okay, so what it will do? Okay, so it will reduce aqueous solution of metal ion. Okay, means aqueous solution means your metal is dissolved in aqueous solution, means water. Okay, or suppose why it is known as aqueous? Suppose it is metal is dissolved in nitric acid. Okay, but nitric acid is not pure. It is suppose 50% nitric acid. So what is this? 50% is nitric acid plus 50% of water. Okay, so it is also contain water. So when this nitric acid dissolve any metal, it is known as aqueous solution. Aqueous solution of metal. Okay, so this solution is known as a aqueous solution. Aqueous solution of metal ion. Okay, so see, now if you will add here, if you add zinc amalgam. Okay, so what this thing will do? It will give 2 electron to this system. Okay, so this M plus will be converted in metal. Okay, so it is reducing from this to this. This is the reduction reaction. Okay, so that's why it is known as a Joule reduction. Okay, then question number 3. Just a minute. Okay, so question number 3 is the 2 methods involved in bulk electrolysis. Okay, bulk electrolysis means it is not means you are going to measure something. Okay, you are going to electrolyte whole your analyte. Okay, so that's why it is known as a bulk electrolyte. Okay, so in bulk electrolyte, generally what happen? Very simple apparatus if we discuss. There are 2 electrodes. Okay, and we need to provide some this is battery, or you can say DC source, which will provide voltage. Okay, so here what will happen? Generally this at cathode. Okay, this is known as cathode, this is known as anode. Okay, so at cathode what will happen? The metal ion, which is in positive form, will gain electron and convert in metal. Okay, so this metal is solid, so it will be deposited on cathode. So the weight of cathode will be increased. Are you able to see? Means initially it was very thin, but as you kept this cathode in solution electrolyte, okay, which contain positive metal ion, okay, so it is converting in metal, and metal is getting deposited on this cathode. So the weight of cathode will be increased. So weight of cathode will be increased, and after complete reaction, you can measure the weight. Okay, initial weight minus final weight. Okay, so the metal which is deposited on the cathode is come from where? It is come from the solution. Okay, so finally you can calculate that how much metal was present in your analyte. Okay, so by this way you can use this technique in analytical chemistry. Okay, analytical chemistry, what we are doing, we are just analyzing now what are or what is our sample content or what is our analyte content. So by this way you can say that how much metal is contained in your, for particular method it is particular voltage and all things we will discuss further, but this is the basic concept behind. Okay, so by this way you can measure particular metal ion. Okay, so this thing can be done by colorimetry and electrogravimetry. Colorimetry means you are giving charge. Okay, charge, why it is known as coulomb? Okay, because 96,480 we can say. Okay, this is the charge which contained by you can say 1 mole of electron. Okay, so this is the particular quantity of charge contained by 1 mole electron. So how much of this charge you are giving? Okay, so by measuring this charge also you can estimate that what is the concentration of your metal ion in your analyte. Okay, so how we will measure? So we know na, means suppose it has sorry, yeah, okay, so this charge we can say Q. Okay, coulomb we can represent by Q. So if you are going to measure total charge, so how much it will be? So total charge Q will be equal to n Faraday, means how much, so how much electron are taking part, okay, in the direction which is known as n. F is Faraday, so this is not Q, this is F. Okay, it is Faraday, no? So it will be, obviously it will be considered as F. Okay, so this is F. So I am writing a simple reaction here. Suppose this Fe plus 2, this is converting in Fe plus 3. Okay, you are oxidizing iron. Okay, in Fe plus 2, Fe plus 3, ferrous to ferric. Okay, you have applied some charge. So you are measuring the charge. Okay, so N means how much electron it require, or it will give 1 electron. Okay, so you can say how much charge will be required for this reaction. So it will be N, how much mole. So to complete 1 mole of ferrous iron in ferric iron, okay, how many mole will be required? So 1 mole of electron will be required. So this N is representing how many mole of electron are required. F is nothing but Farad constant, which is 96,480. Okay, then it is it need to multiply with Na. Na is nothing but the mole of species. Okay, species means metal species. How many moles are there? Okay, initially we calculate for only 1 mole, na, but it is not 1 mole. Okay, it will be depend on your concentration of analyte. So finally, if you write Na, so you will be able to find total charge. Okay. So this total charge by this formula which I just explained you how it is derived. Okay. So by this formula you can calculate total charge, and this total charge will be responsible for deposition of metal. Okay. So by measuring this charge also you can say how much metal is present in your solution. Okay. So this is also a way to find out unknown concentration of your analyte. Okay. And it is very useful in analytical chemistry also. Similarly, electrogravimetry also. Okay, this is similar principle where you are putting constant potential. Okay, suppose you are in electrode, you are maintaining constant potential. At that potential, metal will be deposited. Okay, and gravitometry means you are going to get delta W. Okay, change of weight. Okay, so by this way also you can measure. Okay, these all techniques are interrelated, concepts are same. This is only means some different type of parameters are taken by different method, but overall concept is similar. If you will able to understand, then this whole concept is correlated with each other. Okay, so it will be very easy to understand. Okay, so this is a two bulk method which was called in first option calorimetry is there, but it is amperometry. Okay, so ampere you are going to measure current. Okay, so it is not right. It is not right. It is correct. Okay, so only C has both option correctly. Okay, because it is bulk electrolysis. What we are doing? We are doing electrolysis. Okay, yes. Yes. Amperometry means you are going to measure current. Okay, means you are going to measure current with any change of reaction. Okay, so it is different. It is not in bulk electrolysis. Okay. Okay, so this is all about question number 3. Okay, any doubt in question number 3? Any other student? No? Okay. Then question number 4. The potential required to operate an electrolytic cell in presence of IR drop. The polarization will be. Okay, so first of all, IR drop, as sir has already explained. Okay, suppose what is meaning of IR drop? Okay, so suppose I will explain you in different manner. Okay, suppose this is a battery and you are providing one bulb. Okay, like that. So when this battery is on, this bulb will be glow. Okay, and if you measure potential here to here, okay, so it will be potential difference. Okay, why it is? Because energy is consumed here. Okay, energy is consumed here. Similarly, suppose it is not a bulb, it is simple a resistance. Just a minute. In between these 2 points, I am only adding one resistance like that. Okay, so here also I will be flow. Okay, because it is electron will be flow in this direction, so current will be flow in this direction. Okay, I think you know this concept. Okay, so I will be flow like that, but when because it is resistance. Okay, so it will be restrict to flow electron or flow of electricity. Okay, or flow of current in simple language we can say. Okay, so this resistance means its name says that it is resisting something. Okay, it is resisting current to flow. Okay, that's why what some energy will be consumed here in resistance and your potential will be dropped. Okay, so how much potential will be dropped? So you can calculate it by Ohm law. Okay, what is Ohm law? V is proportional to I, or we can say V is equal to, if you keep constant one constant here, so V is equal to Ri or IR. Okay, so this potential will be decreased here. Okay, this amount of potential will be decreased here due to resistance R. Okay, similarly in our cell, these are the two electrodes, when you are connecting this with battery plus minus. Okay, so this is suppose some electrolyte. Okay, which has some limitations, means their ion mobility and concentration and whatever. Okay, so there are many reasons behind it. Okay, which will restrict the flow of current in the solution. Okay, so this has some resistance. Okay, and due to this resistance, and you are applying the voltage, so current will be flow. Okay, so if you multiply current with this resistance, whatever resistance of this electrolyte, okay, you will get V is equal to IR, and this is nothing but your IR drop. Okay, or potential drop in simple language we can say. Okay, so okay, so the potential required to operate an electrolyte cell in presence of IR drop and polarization. Okay, so first effect is IR drop, which will reduce potential. Okay. Second is polarization. So what is polarization? Again, it is means concept. Let me explain. Suppose this is your electrode. Okay, I am going only first one. Okay, this is one electrode. Okay, so and this is negative electrode, suppose, and it is kept in copper plus 2 solution. So when copper plus 2 solution will come here, what will happen? It will gain electron. Okay, because it is connected from negative side, you can say like that. Okay, so this is the battery and it is connected by negative terminal. So negative terminal will provide electron. Okay, so electron will come like that. Okay, so when electron will come like that, it will react. Please mute yourself. Okay, please don't disturb like that. Okay, so when this electron will react with this copper, it will convert in copper metal. Okay, and the copper metal will be deposited here. This thing is already explained, but why I am repeating again here? Because the concentration of copper ion is not same all over the area of your electrolyte. Why it is so? If you draw the curve, okay, suppose this is the concentration of copper plus 2 ion, and it is here it is concentration of copper plus 2 ion. Okay, and in this side we should go. Okay, and this is the distance from the electrode. Distance from the electrode. Okay, so distance from the electrode, suppose you are going to measure the concentration here, like that. Okay, so I just mark different point here. So this is first point, second point, third point, 4 point, 5 point, 6 point. Okay, so these are the different points where we are going to measure the concentration of copper ion. So it will be very low here. It will be it is straight line. After that it is straight. Okay, so why it is very low here? At surface of, or you can say at interface of electron, it is very concentration is very low. Okay, suppose you can say this is the first point. Okay, this is the second point, and after as you are moving apart from the electrode, the concentration will remain constant. After that the concentration is constant like that. Okay, why it is so? Because here at the interface of electrode, copper plus ion will be converted in copper metal. Okay, so copper, it will convert in copper metal. So obviously concentration of copper plus 2 ion will be decreased. Okay, and initially when reaction when it is copper plus 2 ion converting in copper completely, so here concentration is copper plus 2 ion concentration is negligible. Okay, but it will be like that. Okay, so it is known as then what is the polarization effect? Okay, so due to concentration difference, okay, now again another copper ion from here to here, it need to move. Okay, then only reaction will be continue, no? Okay, so initially when current is low, when suppose it is I, okay, so initially when current is low, it will, okay, so what will happen? It will follow the rule. Okay, it will be like that. Okay, I will show you this again clearly, but here for understanding only, you can say current, you are increasing the current. Okay, initially what will happen? Initially it will be also increased. Okay, just a minute. It is nothing but E applied. Okay, whatever potential you are applying, initially when you potential will be applied, current will be also increased. Okay, but after some time you are applying potential, means you are increasing potential. How you can increase your potential? From your battery. okay, from your DC source. You are increasing the current, or sorry, not current, you are increasing your potential, but I will be, after some time I will be not increased. Okay, it is due to, because it need some copper ion need to come here. Okay, and there are many effects like diffusion. Okay, diffusion, then migration. Okay, and one more, I think it is a diffusion, migration, and convection. Okay, so these are the effects which are responsible for this polarization. Okay, so finally we can say the potential required to operate an electrolyte cell in presence of IR drop and polarization will be, okay, so these two effects, IR drop and polarization, is decreasing your potential. Okay, decreasing potential here. So the potential required for this reaction will be not sufficient. Okay, so what then what we need to do? We need to increase potential to complete this reaction. Okay, that's why the greater than thermodynamic potential. Okay, so potential you need to apply will be greater than thermodynamic potential. Then what is the thermodynamic potential? It is measured both from Nernst equation. Okay, you can measure potential by Nernst equation. Okay, if you want to oxidize or reduce any metal, you can calculate potential from the Nernst equation. But in the real case, you need some higher potential. Why it is required higher potential? Due to IR drop and polarization. Okay, so this is the all about this question. Clear? Any doubt here? Okay. So in simple language it is written here, the potential required operating an electrolyte cell in presence of IR drop, okay, it is drop means potential drop. Polarization is greater than thermodynamic potential. Okay, thermodynamic potential, you can say other language, Nernst potential, because to overcome these two factors. Okay, overcome means due to this IR drop and polarization, your potential is decreasing. Okay, so we need to complete the reaction, so that we require specific potential. Okay, so to compensate this phenomena which are IR drop and polarization, we require higher potential. Okay, I think it is clear. Okay, then question number 5. IR drop can be minimized by, okay, now we are going to minimize IR drop. Okay, I think you have already understand what is the IR effect and how we can drop. Okay, means IR effect, it is due to resistance. Okay, resistance of your electrolyte, your electrode, and whatever system you have. Okay, so how you can minimize your resistance? Okay, if your current will flow easily. Okay, and when current will flow easily, when it has sufficient ion. Okay, if your electrolyte has sufficient ion. Okay, then means current will flow easily. Okay, so using supporting electrolyte, obviously. Okay, if you are adding more electrolyte, then current will flow more easily, because it will give some ions which will be responsible for flowing of current. Okay, so it will be obviously help in IR, it will reduce IR drop. Okay, then using auxiliary electrode. Okay, so this thing will also be explained. Okay, I will explain to you how auxiliary, because sir also explained that when you use auxiliary electrode, this auxiliary electrode, negligible current will be flow. Okay, so IR drop means what? I into R. Okay, so if you are reducing I, okay, then R will be remain constant, then overall this value will be decreased. Okay, so by this way also you can decrease your IR potential. Okay, what you are doing, you are reducing I. Okay, so by this way also you can reduce IR potential. So obviously A and B are correct answer. Okay, so we can reduce IR drop by using supporting electrolyte as well as auxiliary electrolyte. Okay, so it is explained here. Usually we try to minimize the IR drop in the cell using supporting electrode or by using special 3 electrode. Okay, 3 electrode means reference electrode, same. Okay, cell in which the current passes between the working electrode and auxiliary electrode, or auxiliary electrode also known as counter electrode. With this arrangement, only a very small current passes between the working electrode and the reference electrode. Okay, so same concept it is written here. If current will be flow, okay, current will be less, your IR will be less. Okay, thereby it will mean IR drop. Okay, so if you understood this thing, it is very good. Otherwise I can show you how it will be look like. Okay, how your cell will look like. Okay, so just I need one slide which is clear. Okay, so here you can say there are 2 electrodes and one is there. Okay, this arrow is representing reference electrode. This is the counter electrode. Counter electrode, or it is also known as okay, just a minute. And this is the working electrode. Okay, it is also known as auxiliary electrode. Counter electrode is also known as auxiliary electrode. This is working electrode, and it is a reference electrode. Okay, so why we are using 3 electrode here? Okay, so simply we are going to reduce IR drop. Okay, if you see the total structure of this cell, then you will be able to understand. Okay, so it is very simple. Here I am providing one voltmeter. Okay, it has very high resistance. Resistance high means IR will I will be low. Okay, so only very small amount of I will able to flow in this circuit. Okay, but this circuit is connected. Just a minute, let me complete. This is potential state. Okay, then we can connect this counter electrode like that. Okay. You can say about battery here, DC source, then it is finally connected. Okay, so this is switch, you can connect it, it is switch. Okay, so now understand how it will be work. Okay, you are applying DC, means you are applying voltage in between these 2 electrode, which is working, this is working electrode, okay, and counter electrode. So you are applying current in this. Okay, so it will cause IR drop because this is the electrolyte, so it has some resistance, and due to this IR drop will be there. But we are arranging, so this is the first assembly, this is the second assembly. Okay, so in first assembly what we are doing, we are adding one reference electrode. Okay, and here we are providing a voltmeter. This V is representing voltmeter, which has very high resistance. Okay, so because it has very high resistance, so very minute amount of I will be flowing. Okay, so because I is very less, so IR drop will be very less, and you can manage a constant potential here. Okay, here I just missed one ammeter will be here. Okay, so this ammeter will be count current, where this V for voltmeter it will be calculate voltage. Okay, so this is the overall assembly which can be used. okay, to measure these things, okay, and we can reduce IR drop. Okay, so if you see here, okay, it is sufficient here. Okay, question number 5 is clear. Any doubt in this assembly, or if you want to clarify some other doubt, you can ask here. No? Okay. Then question number 6. Match the following. Migration, what is the migration, convection and diffusion? Okay. So I have already explained you how it will be there. So, okay, no need to go like that. Just a minute. Okay. Suppose this is your electrode. Okay. And I told you that whatever ion which is very near to, I think it is positive ion. Okay. So whatever ion which is very near to the interface of electrode, it will be converted in negative ion. Alright. Okay. By taking electron. Okay. So other ion which are far from the electrolyte need to come near electrode interface. Okay. You can say one more here. Okay, so it can come, their movement from here to here depend on 3 phenomena. Okay, what are the 3 phenomena? First is, you can say, diffusion. Okay, so what is the diffusion? Diffusion means higher concentration to lower concentration. Okay, suppose you have smell somewhere. Okay, so suppose you are suppose in your room smell is in one corner. Okay, some type of smell is there. Okay, so after some time the smell will be spread in all over the room. Okay, it will be spread all over the room. Okay, smell will be or you can say, if somebody is opening perfume bottle in the one corner of room, the its fragrance is spread all over the room after some time. Okay, it is due to diffusion. Okay, here the concentration will be high, C1 into C2. If you can say, here in this corner concentration of this fragrance is C1 and here it is C2. So what is this? C1 is very high, greater than C2. Okay, so the particle is moving from here to here. Okay, particle are moving from here to here. So from where? From higher concentration to lower concentration. Okay, so this is known as diffusion. So similarly here, particle will move from here to here. Okay, so here concentration will be high. This ion concentration will be higher here, but at electrode interface, the concentration will be low. Okay, so due to diffusion, from higher concentration to lower concentration, this phenomena will be happen. Okay, so I think diffusion is clear. Then migration. Okay, so what is the meaning of migration is, this is the negatively charged electrode. Okay, this is the negative charged electrode and these ions are positive. Okay, so because it has these ions has opposite charge with electrode, so it will be attracted, okay, by this electrode and then it will move toward electrode. This is the second phenomena. And third phenomena, it convection. Convection is means you are giving some external influence, like you are stirring your solution electrolyte. Okay, you are stirring your electrolyte, or you are whatever you are doing. So you are influencing from the outside. So this is the third phenomena where these ions will move toward electrode surface. Okay, so these 3 phenomena are responsible for flowing of current. Okay, and it is also responsible for polarization of electron. Okay, polarization of your electrochemical cell, you can say, or electrolytic cell. Okay, so now I think I have explained you very nicely this thing. Okay, now I will clear this question. What is the migration and whatever. Just a minute. So what is the meaning of migration here? Okay, what is the meaning of migration? So migration is first of all the movement of species under the influence of concentration gradient. Okay, so delta C upon delta X. This is the concentration gradient. What is meaning of that? Delta C means change in concentration with respect of distance. Delta X means distance. Okay, so this is obviously it is a concentration gradient is responsible for diffusion. Okay, so first statement is for diffusion for diffusion only. Then second, the movement of ion through a solution as a result of electrostatic attraction. Electrostatic attraction. Okay, negative ion, your electrode was negative ion and your ion was positively charged, so they are attracting. Okay, so so ions are very small size, so obviously they will move toward electrode. Okay, so the movement of ion through a solution as a result of electrostatic attraction between the electrodes and the ions, it will be due to what? It will be due to migration. Okay. Okay. Then finally, the transport of ion or molecule through a solution as a result of stirring. Stirring is what? You are stirring your solution, so you are providing external energy source. Okay. It can be also vibration. Okay, you can vibrate your solution. It will be also some type of mechanical energy you are providing, or temperature gradient. Okay, if you are heating your solution, then also due to temperature gradient also this ions will be moved. Okay, and it will be responsible for movement of ion. Okay, so these two phenomena are responsible for the ion movement. Clear? Any doubt? Up to here, any doubt? No? Okay. So let me check if somebody write in chat box. Okay, sorry for inconvenience. This connection was lost. Okay, are you able to hear now? I think you are able to hear now. Okay, okay. Just a minute. Let me share the screen. Okay, screen is visible. Hello, screen is visible to you. Are you able to see my slides? Okay, so means when the connection was when you people disconnected, means are you able to understand this question, migration, convection, diffusion, or not? Are you able to understand this question which I explained you? Okay, in fifth lesson only. Okay, so I drop I have explained, so I have to explain this again. Okay, so here we are discussing about what are the what are the phenomena which are responsible for polarization of your electrolytic cell. Okay, so as I already explained you, these are the three phenomena: migration, convection, and diffusion. So we will discuss one by one. Okay, because we need to match this thing. Okay, whatever. The movement of species under the influence of concentration gradient. Okay, concentration gradient means, suppose you have one room and you are opening one perfume bottle in one corner of this room. So after some time, the fragrance will be spread in all over the room. Why it is so? Because suppose it is C1 concentration and here it is C2 concentration. So obviously C1 is very higher than C2. Okay, so due to concentration change, or we can say concentration gradient change. Okay, so how the concentration gradient is measured? Delta C upon delta X. Okay, delta C is change in concentration and delta X is change in distance. Okay, so according to this concentration gradient, diffusion will be there. Okay, it is known as a diffusion. So if you are able to smell, if you are able to experience this fragrance of this perfume in the another corner of this room, so what is the responsible phenomena for that is it is a diffusion. Okay, and it is caused by concentration gradient. Okay, so this first statement is for the movement of species under the influence of concentration gradient, so it is known as diffusion. Okay, so just a minute. So obviously this is the diffusion. Then the movement of ion through a solution is a result of electrostatic attraction between the electrodes and the ions. Okay, so your electrode is negative, okay, and this ion is positive, so it will be attract toward electron. Okay, due to opposite charge it will be attract. Okay, and this is known as a migration. Okay, due to opposite charge the ion will be moved, so it will be due to migration. Okay, second phenomena is also clear. Then third is convection. Convection is means you are providing any mechanical energy from mechanical or any type of energy from outer source. Okay, then movement of ion due to this external energy will be caused, and it is known as convection. Okay, so this is the third statement is the transport of ion or molecule through a solution as a result of stirring, vibration. Vibration is also one kind of energy only. Okay, you are providing energy due to vibration. Okay, or temperature gradient. If temperature gradient is also, then also your ion will move. And movement of ion due to this energies is considered as convection. Okay, so this is the three phenomena which are responsible for ion movement. Is it clear? These three phenomena are clear now? Okay. So I will read this statement. Diffusion is a movement of species under the influence of concentration gradient. I have already explained what is concentration gradient, delta C upon delta X. Okay, changing concentration with respect of distance. Okay, here to here. So it is X1, X2, X3. Concentration is C1, C2, C3. Then what will be delta C upon delta X? You need to find out concentration difference. So it will be C2 minus C1. Then you need to find out distance. So it will be X2 minus X. Okay, this is known as a concentration gradient. Okay, if you some chemistry students are not able to understand this gradient at all, so I explained it very simply. Okay, so it is the process that caused ion or molecule to move from more concentrated part of solution to more dilute. Okay, this is all about diffusion. Then migration is the movement of ion through a solution as a result of electrostatic attraction. And electrostatic attraction is nothing but positive negative attraction. Okay, between the electrode and ion. Okay, it is clear about migration. Then third, convection is transport of ion or molecule through a solution as a result of stirring, vibration or temperature, whatever energy you are providing from the external source. Okay. X is distance. Suppose this is your electrode, na? Okay, this is the electrode and this is the electrolyte. So you are moving far from the electrode. So means if suppose here it is concentration C1, so if you are moving from the electrode, the concentration of ion will be changed. Okay, so you are going to measure means what concentration will be changed if you are moving apart from the electrode. Okay, clear? Then this is the very simple question. The Coulomb C is the amount of charge required to produce. Okay, so means the Coulomb charge is fixed. What is this value? 96,000. Generally we calculate by 500, but it is actually 96,480 like that. Okay, so whatever you can take. So if you are providing this amount of charge in your electrolytic cell, okay, minus plus, okay, if you are providing charge, then suppose this is the solution of AgCl. Okay, AgCl means Ag plus and Cl minus, obviously, because it is electrolyte, so it will be dissociated in Ag plus Cl. So how much amount of silver will be deposited, and where silver will be deposited? Silver will be deposited negative ion. Okay, it is known as a cathode. I just draw this cell opposite cathode anode. Okay, otherwise generally cathode we write cathode in right hand side. Okay, but here it is left hand side. But your concept should be clear. Okay, because it is Ag plus. Okay, so it will take electron from the negative electron and convert in silver. Okay, so how much quantity of silver will be deposited? This is the question. Okay, how much charge you are providing? Charge you are providing only 1 coulomb, which is equal to 96,480. Okay, you are providing only this amount of charge. Okay, so this amount of charge will be able to deposit only this amount of silver. Okay, it is already calculated value, so you need to memorize only, otherwise nothing is there. Okay, but the concept behind it, what is meaning of 1 coulomb? Okay, 1 coulomb means how much charge is there, then this is the charge, and what we can say, this is the Faraday. Okay, Faraday constant, and what else you can say. Okay, it is sufficient for this question. Okay, so it is all 1 over. Electrical charge is the basis of other electrical quantity. Okay, current, voltage and power. The charge on the electrode and proton is defined there. I think this is clear. Okay, 1 electron and 1 proton. Okay, 1 proton we can say hydrogen ion H plus. Okay, either it is 1 electron or 1 proton. They have charge 1.6022 into 10 raised to the power minus 19. Okay, minus 19 is for electron, and if it is plus 19, then it is for proton. Okay, so the rate of change flow, the rate of change flow equal to the 1 coulomb per second is definition of 1 ampere. Okay, so how much you are 1 coulomb per second. Okay, in 1 second only you are providing 1 coulomb. Okay, so in your circuit 1 coulomb of charge is passing in 1 second only. Okay, it is known as an ampere. The coulomb is the amount of charge required to produce. Okay, if you provide this amount of charge, this amount of silver will be deposited. Okay, first of all you have defined this thing. After that you can say means reversely. Okay, so whatever charge is able to provide this amount of silver, which will be equal to 1 coulomb, like that. Okay, so this is all interconnected. Okay, so like that you can say. And yeah. Sorry, yes, yeah, option are incorrect, you are right. This is same, this is incorrectly, this is only my next statement. Okay, these all options are correct, you can say. Okay, so somebody, I think, yes. Okay, then. Okay, Arjun, you wrote something, means you are going to, you calculated this thing, 107, take 96.5. Okay, so it is what's say molecular weight of silver, atomic weight of silver, sorry, right, that 107, then you divide by coulomb, so this amount of, okay, it is also same, because 1 mole, okay, what is concept behind that is, one mole, okay, one mole uh, 1 mole of silver. Okay, so what is the weight of 1 mole silver? Anybody, just let me check. I think it is 1738. Just a minute, let me check. Yes, silver atomic mass is 108. Okay, so means 1 mole of silver is there, and it has 108 what say 108 gram. Okay, so it is 108 gram. So how you will calculate means this amount of silver only required. Okay, so just a minute. I do not have slide for that. Okay, but okay, so it is 108 gram. Okay. But how much what we can say charge 96,500 for one. Okay, so if 96,500 okay, it means it can you need to divide it. Okay, so it is means if 108 gram can be deposited by 96,500. Okay, so how much 1 coulomb can be 1 Faraday means 96,500. Okay, so how much 1 coulomb can be if you are applying 1 coulomb, then how much it will. So you need to divide, so you will be able to find out this quantity. Okay, you can check it. I think it will be 108 divided by 96. Yeah, it is approximately same. Okay, so okay, so this question I think very well explained. Then question number 8. Are you able to see my screen? Okay. Question number 8. The reference electrode used in electrolytic cell of potential calorimetry is. Okay. So reference electrode, it is simply I just draw the whole circuit now. Okay. So I also mentioned reference electrode. Okay, it is nothing but standard calomel electrode. Okay, we generally use calomel electrode for that. The instrumentation of potential, this instrumentation already discussed. Okay, so I am not going again. The instrumentation for potentiostatic calorimetry consists of an electrolytic cell, a potentiostat, and a device for determining the charge consumed by the analyte. Okay, so this is different thing. The electrolysis cell consists a platinum gas working electrode, a platinum working counter electrode. Okay, so these two electrodes are responsible for current flow. Okay, and a saturated calomel reference electrode. This is for reduced ion flow. The counter electrode is separated from the alkaline solution by a salt bridge that usually contain the same electrolyte as the solution being analyzed. The salt bridge is needed to prevent the reaction produced foam at the counter electrode from diffusion into the inert solution and interfering. Okay, so this is all about the working of this instrument. Okay, but this is only thing why we are using standard kilometer electrode. Question number 9. The electrode. Yeah. Sorry. Can you repeat? Hello. Can you repeat your question? Yes. Yes, you are audible. You are. Yeah. Can you repeat once more? I am not able to hear anything. Okay, so you can write me in chat box. If you are in doubt, you can write in chat box. Can AgCl? Yes, AgCl also can be used. Okay, reference electrode you can also can use, but it is some significant. I think it is that's why it is already mentioned. I am not very familiar with how to compare this electrode, but generally mercury electrode is only being used. Okay, so what are the advantage and disadvantage? We need to we need to find out. We need to investigate more about this. Okay. So next question is question number 9. The electrode that can be used above 60 degree. Okay, so above 60 degree. So we are using silver chloride electrode. So in your previous question we can say that if your electrolytic cell is operating at higher temperature, then your reference electrode should be silver chloride like that. Okay, so means selecting of reference electrode also depend on what? It is also depend on your operating parameters. Okay, what are the temperature and whatever other things. Okay, so we need to wisely choose our reference electrode. Caramel electrode is not there because caramel is made by mercury is there. Okay, so it is not wisely advised to use caramel electrode at higher temperature, because mercury will be vaporized and it will not give good thing. Okay, that's why only silver caramel electrode is used. Question number 10. It is last question. The component of the control circuit in a control potential apparatus is control potential. Okay, I have already explained you. So control potential contain a reference electrode, which we discussed like that. Na? This is a reference electrode, then one voltmeter like that. Okay, then it is connected like that. Okay, then it is connected with the battery and whatever potential state and like that. Or you can say DC source. Okay, so it is I am just drawing this part only. Okay, so one more here. So this is only we are talking about this portion only. Okay, this is your cell, electrolytic cell, which is represented by small circle. So the component of the control circuit in the control potential apparatus. Okay, so we need to maintain control potential. So it will consist one reference electrode, a voltmeter, this reference electrode, and this is working electrode. Okay, so these three things are part of this control potential apparatus. Okay, so this is the right answer: reference electrode, voltmeter, and working electrode. The control circuit is made of reference electrode, which is generally calamine electrode, saturated calamine electrode, a high resistance. Okay, you potential. Okay, what is the what is the specification of voltmeter? It is high resistance. Okay, so which will be able to flow negligible current. Okay, and the working electrode. The electrical resistance of the control circuit is so large that the electrolytic current supply essentially all of the current for the electrolyte. Okay, means I'm just repeating it. The electrical resistance of the control circuit is so large that the electrolysis circuit supplies essentially all of the current of electrolysis. Okay, so the main these two electrodes are there, na? Like that one. Okay, so these two electrodes are taking what's say all electrolysis current. Okay, these two electrodes. The control circuit monitor continuously the voltage. Okay, here voltmeter is there. Okay, so it will continuously measure the voltage from here voltmeter. Okay, the control circuit monitor continuously the voltage between the working electrode and reference electrode and maintain it at the controlled value. Okay, so the voltage will remain constant and we will maintain in control value. Okay, by the potential step. So this is all about this 10 questions of previous semester. Okay, so if you people have any doubt, you can ask. Otherwise, we will discuss some question. In assignment 10, question 2, option B, D are 1 and the same. Question number 2. Miss, are you asking about this thing? Hello? Are you asking about ongoing assignment? I have to read this thing because I am not allowed to discuss about the ongoing assignment. Okay. So you can ask this question separately, okay, by mail or then we will discuss. Okay. Okay. So this is all about this assignment. Any other doubt? Any another doubt? Hmm. Huh. Yeah, it is only derivation means simply just a minute. I need one lens out. Okay, so you are means okay. So this type of curve will be there. Okay. It is for what? Just let me explain. This is okay. This is simple curve of suppose pH change. pH change with volume of your titrant. Okay. As you are adding, okay, at some time the pH will be changed. Okay, why pH is changing? Because your you can say your background or your analyte which was acidic, now it is converting in basic. Okay, suppose neutralization reaction is there. Okay, so if you add one more drop of your titrant, okay, suddenly the pH will be increased like that. Okay, it is at very this particular point of your titrant volume, the pH will be changed. Okay, so at that point you can find out n value. Okay, similarly, if we are drawing like that, suppose it is potential. Okay, we can measure in volt, and this is volume of right. Okay, so here Here also potential will be changed at certain volume of this thing. Okay, means what is the meaning of that? Means as you are adding any means titrant, okay, some oxidation reduction or redox reaction, okay, this type of reaction is happening there. Okay, so uh, this reaction is completed at that point. Okay, so you need to find out end point. Okay, but by this curve you to finding out end point is very difficult. Okay, so what is it is done is we need to find out derivative plot. Okay, so what is derivative plot is delta E upon delta V. What is meaning of this thing? Can you explain? Do you know delta E upon delta V? Means you are taking a small difference of delta E with respect of small difference in volume. Okay, means how I can explain? Suppose it is you are calculating potential E1, E2, E3, E4. Okay, in apparatus. Okay, means it is continuously counting the value of your potential. Okay, potential of your cell, and volume is V1, V2, V3. Means you are adding volume like that. Okay. So from this point to this point, okay, so what will be difference of delta E? Okay, and volume change is delta V. So when you are adding volume here, you can say that potential is not changed very much. Okay, so this value will be very you can say very low, or okay, means approx 0 at this point. Okay, but at this point, as you are adding small amount of volume, delta E, which is potential, is changing drastically. Okay, so delta E upon delta V value will be very high here. Okay, did you understand why it is very low here, around 0? You can say around 0 here. Why it is around 0 here and why it is very high here? Did you understand? Okay, means the difference between delta I. Okay, means you are taking small differential. You are doing differential means what? You are the continuous reading. You are dividing your continuous reading in small segments. Okay, because here suppose it is E4 E5. Okay, this reading here you are taking at any point, it is E5 minus E4. Okay, and volume is also, you can say, V5 minus V4. So this value will be very high here. Okay, because the potential is increasing very drastically here, but here potential is not increasing drastically, so delta E value will be around 0. Okay, delta E value will be around 0, so 0 divided by anything, okay, it will be all about 0 only. Okay, so if you plot delta E upon delta V here, okay, it will be a straight line. Okay, because delta E with respect to delta V is not changing. Okay, but when you reach at this point where it is changing drastically, you will get peak like that. Okay, so by this peak you will able to find out that at which value of your titrant the delta E change, the change in delta E value is highest at which point. Okay, so this will give you very accurate reading. Okay, now if we are further differentiate this equation, then it will be delta E delta V square. Okay, it is mathematical, so it is hard to understand, but it will also give you negative reading also. Okay, so it will give curve like that. It is not very symmetrical, but I just make you to understand. Okay, so at that point you will able to find out that which volume is which volume of your titrant the reaction is completed. So you can find out your endpoint. Understood? Okay. So this is all about this thing, but we have more time. So I will take 5 minute rest, okay, because it is very. Then we will again discuss some concept about what's a of which sir has taught in the lecture. I will just revise this concept, okay, and also you can ask if you are not able to understand some concept, then we can discuss further, okay. So after 5 minutes I will continue. You people also can take rest for 5 minutes. Then. Okay, student. So we have around half an hour more. Okay. So we will discuss about this concept. Okay. First of all, in this remaining time, we will discuss about electrogravimetry, introduction, factors affecting the nature of the deposit, then little bit about the instrumentation, and finally application of electrogravimetry. Okay. So as we have already discussed electrogravimetry, the product is weighted as the deposit. Okay, how much material is deposited, it is weighted and it is known as electrogravimetry. Okay, and which electrode will be responsible for depositing? It will be the working electrode. Okay, so deposition desired metallic element upon a previously weighted cathode. Okay, your cathode size will be fixed. Okay, and when you applied the voltage, the metal will be deposited. Okay, and it will be calculated, because you can take the weight difference before and after. Okay, and followed by subsequent reweighing of the electrode pulse deposited to obtain by difference the quantity of metal. Okay, so these are the very common metal which can be measured by this way. Few substances may be oxidized. Okay, means it is not compulsory that always it will be reduction also. Okay, we discuss about like this type of reaction where iron is converting in metal, so and it is depositing on cathode, so it is a reduction reaction, but it is not compulsory. Sometimes few substances may be oxidized at platinum anode to form a insoluble and adherent precipitate suitable for gravimetric measurement. Okay, so sometimes it will be oxidized also. Okay, so example is given here, like lead dioxide. Okay, it will make PbO2 and it will make PPT. Okay, precipitate. So by this way also you can measure the weight of PPT you can take, and you can measure the analyte concentration. Okay, the substance may be oxidized at platinum anode to form insoluble and adherent precipitate suitable for gravimetric analysis. Okay, by taking weight you can measure it. Okay. So cells we have already discussed in previous week. We discussed about the electrochemical cell. Okay, so what is the electrochemical cell? It is generally is cell. Okay, in general language we can say battery cell, whatever. Okay, so means when you add battery with any source, no, if you add battery is what? Battery is energy source. If you are adding this battery in any circuit, okay, so it will provide voltage, because it has suppose 2 volt. Okay, so it will provide 2 volt. Okay, and it will do some work. Suppose it is a R resistance, so it will do some work and whatever. Okay, so means you need not to do anything in your battery. Means the reaction which are occurring inside this battery is spontaneous redox reaction. Okay, spontaneous redox reaction is not compulsory, because some batteries are irreversible also. Okay, but galvanic cells are generally reversible, so it is written here spontaneous redox reaction. But here in this week we discuss about the electrolytic cell. Okay, so in electrolytic cell we provide energy from the outer source. Okay, so this reaction is not spontaneous. Okay, means metal is depositing on cathode and whatever. So this reaction is not spontaneous. You are providing some charge, some voltage from the outer source. Then the reaction will be occur. Okay, so electrolytic cell. What is if we discuss about little bit about the electrolytic cell? So the anode of an electrolytic cell is positive. Okay, so positive electrode is anode, and negative electrode is, this is the positive electrode and this is the negative electrode. Okay, cathode is a negative electrode. Since the anode attract anion from the solution, it is negative. Okay, it is negative, so it will attract positive ion, whereas it is positive, so it will attract negative ion. Okay. Then possibility for electrolysis. Okay, so possibility we will discuss about the applied voltage. Okay, what voltage we need to apply so that our reaction can be complete. Okay, means our what reaction, reduction or oxidation, whatever reaction is going on in cell. Just a minute. Okay, just a minute. Are you able to see my screen, na? You people are able to see my screen or not? Okay. Okay. So E applied E cell. Okay. Suppose you are measuring your E cell by Nernst equation. Okay. You can calculate cell potential by Nernst equation. Okay. Obviously. So if you are applying only potential according to Nernst equation, then no current flow in the cell. Okay. Because it required a little bit higher voltage, which we have already discussed. Why? It is due to IR drop and polarization of your electron. Okay, so these are the two things which required extra voltage. Okay, it required some voltage drop. That's why you require E applied should be higher than E cell. Okay, then only current will be flow in the cell and electrolysis takes place. Okay, so this is the thumb rule that your E applied will be higher than E cell, then only reaction will be proceed. Okay, so these two things, two dry and endothermic electrochemical reaction, the applied voltage must overcome the, what should be overcome? Cell potential and IR drop. Okay. So IR drop is what we have discussed, but let me introduce more points. Note that the electrochemical cell has resistance. Okay, obviously we discussed about by simple circuit we understand how resistance will be work and how it will be responsible for voltage drop. Okay, so electrochemical cell has resistance to current flow in analogy with resistance of current flow in any conductor. Okay, so whatever conductor is there, it has some resistance. Similarly, our electrolyte is also able to charge current, however it has some resistance. The relationship between voltage, current and resistance in Ohm law, okay, V is equal to IR. So this is the resistance of your electrolyte, okay, and other system, okay, and suppose current is flowing, okay, so this will be V is equal to IR. So IR will be potential flow, okay, where E is potential, or we can say voltage, I is the current and whatever. Okay, so this will be potential drop. So the factor influencing the physical characteristic of deposits. Okay, whatever metals are depositing on cathode. Okay, what are the factors which are responsible? So these are the current density. Okay, how much current density, this how much charge you are providing. It is only current, you can say delta Q upon delta T. Okay, then temperature, then presence of compressing agent. Okay, if compressing agent is there, then it can trap some ions. Okay, means it can trap some, suppose it is Sn plus 2 and Sn plus 4. Okay, so two types of ion are there, and if you are adding tartrate, okay, so it will trap Sn4 plus and only Sn plus 2 will be deposited. Okay, so presence of complex reagent also will be affect this thing. The effect of temperature are unpredictable and must be determined empirically. Then many metals form smoother and more adherence film when deposited from the solution in which their ion exists primarily and complex. Example, cyanide and ammonium complex. Okay. So principle of electrolysis. Electrolysis is the process in which a reaction is driven in non-spontaneous. Okay, it is very clear, because you are providing energy from the DC source or battery. Okay, so you are providing energy from the outer source, so it is non-spontaneous direction by the application of electric current. Okay, so by Nernst equation you can calculate. Okay, by Nernst equation you can calculate potential required. Okay, 509 and log concentration of your you can say C1 C2 log. Okay, so this is not equation, you can calculate it again. Okay, so by the concentration of all this your electrode and your analyte and whatever, okay, according to your reaction how many electrons are taking part, you can calculate this potential. Okay, but this potential is not sufficient. Okay, standard oxidation potential and standard reduction potential can be calculated, but no Nernst potential is why, because this ohmic potential V is equal to IR. Okay, IR drop, it is known as ohmic potential also, concentration, polarization, over potential voltage. Okay, so these things are not included in Nernst equation, so that's why we are discussing here non-Nernstian potentials. Okay, so this potential also should be considered, that's why we need to apply little higher voltage. Okay, so if we discuss about the basic structure of electrolytic cell, so here this is copper electrode, this is platinum electrode. Okay, how this is the variable voltage. Okay, means what is the meaning, this is battery only and this slanting arrow representing that you can adjust your voltage. Okay, so this is the variable voltage source. Okay, so what is happening here, it is connected by positive voltage and it is connected by negative voltage. Okay, so negative voltage and positive voltage. Obviously it is cathode. Okay, it is anode. So if you see the reaction here, copper plus 2, it is converting in copper sulfate, copper solid. Okay, so copper metal converting in copper solid. It is taking 2 electrons. So from from where these 2 electrons are coming, this these 2 electrons are coming from this battery. Okay, because it is only electron source. This battery is electron source. These electrons are flowing like that, and it is coming on this electrode, and copper plus 2 ion which is present in solution in your electrolyte is converting copper. Similarly, at platinum electrode, what will be happen? Other reaction will be happen, which will provide 2 electrons. Okay, this electron will be given to platinum electrode, and this electron will be reached to the positive terminal, because electron and positive electrostatic attraction will be there. Okay, so finally this is the reaction. At anode, it is H2O, and it is okay, it is also half oxygen plus 2 hydrogen and 2 electron. Okay, so this, it is producing 2 electron. Here this reaction is happening here. Okay, water is creating in oxygen, 2 hydrogen ion and electron. Okay, so this electron are by this reaction electrons are producing, but by this reaction electrons are consuming. Okay, so overall net reaction is H2O plus copper. Copper will be deposited and it will make oxygen plus hydrogen. Okay, so this is the working principle and how oxidation and reduction will be happen by the applying of external voltage. Similarly, here in this cell, you can say, this is first of all we will discuss a little bit about this cell. How much time we have? Okay, we have 20 minutes more. So this is the Ag electrode, this is the cadmium electrode. What reaction is going on? Ag is converting in AgCl. Okay, and it is Cl solution. This is the molarity, you can say 0.2, and another is another electrode is cadmium. Another solution is cadmium plus 2. Okay, which is connected by cadmium electrode. Okay, so this is here, it is also written here, cadmium has this molarity and chloride has this molarity. Okay, so if we measure voltage in between these two terminal, it is minus 0.734. Okay, before applying this current, the potential is this one. Okay, so now we will discuss a little bit about the reaction. Here what is happening here, Ag is converting in Ag is converting in Ag plus. Okay, by this. This is only representation of cell. Okay, we discussed in last class. Okay, so here it is representing that Ag is converting in Ag plus. Okay, and here it is representing cadmium plus 2 converting in cadmium. If you add these two reaction, finally you will find cadmium plus 2 converting in cadmium, which I wrote here. It's same thing. Okay, and Ag is converting in Ag. You see, it is AgCl, but it is Ag plus only. Okay, you can understand because it is Ag and Cl minus I. Okay, Ag plus and Cl minus I. Initially it was metal, but it is reduced. Okay, so this is a redox reaction. Okay, working electrode operates as a cathode when apply a potential somewhat more negative than a thermodynamic. Okay, so if you are making this cell, its potential is minus 734. Okay, so to deposit this cadmium, okay, you need to apply little more voltage compared to 0.734. Okay, so this is what we are going to say. Then current and potentials are during electrolysis. Okay, so ohmic potential we have already discussed. I will not discuss again and again. Okay, V is equal to IR. So finally you need to okay, so E galvanic or E of cell, potential of your cell will be E equilibrium, which is calculated by Nernst equation minus IR. Okay, so it is also E right minus E left, or E cathode minus E anode minus IR. Okay, so finally E applied will be E cell minus ER. Okay, it is already discussed, so I think it is clear. Okay, then second factor is polarization effect. Okay, which already discussed. Okay, due to concentration gradient of your this thing electrolyte. Okay, how polarization will be there we have discussed. Okay, so I is equal to E cell minus E applied by R. This is what E cell minus E applied means what extra you are applying. Okay, what extra voltage you are applying. This delta E cell minus E representing delta E, and this delta E showing that how much extra potential you are applying. Okay, so delta E divided by delta R, divided by R will be equal to E. This is nothing but Ohm's law. V is equal to IR. So for I it will be equal to V upon R. V is nothing but electric potential. Okay, so this equation is coming from Ohm's law. Okay, so finally we can say E applied E cell minus this ohmic voltage minus polarization effect, which is represented by capital pi. Okay, so the term polarization refer to the deviation of the electrode potential from the value predicted by Nernst equation. Okay, on the basis of current. Okay, so how much which term is there? I am reading again. The term of polarization refer to the deviation of the electrode potential from the value predicted by Nernst equation on the basis of current. Okay, cells that exhibited non-linear behavior at higher current exhibit polarization, and the degree of polarization. Okay, what we discussed now, like that curve. This curve should be like that. Okay, as you are increasing voltage, the current should be increased like that, but it is not like it is something like that. Okay, so this thing can be explained by polarization. Okay, like that. In this curve, it is very nicely drawn here, so we can explain. Yeah. What? No, what you are saying? Just this one, no? This one only? Ha. No. See, no. See, the current. If you see this thing, no. See, this is the minus 734. Okay. So generally what happen, if you go for electrochemical series, Ag is converting in Ag plus. So this reaction is spontaneous or this reaction is spontaneous? Do you know? This reaction is spontaneous. Means Ag will be converted in Ag. Ag plus will be converted in solid Ag. Okay. Ag has positive reduction potential. Got it? Ag has positive reduction potential. Okay. So means Ag ion will be converted in Ag. Okay. But here what we are doing, Ag is converting in Ag. This solid is converting in Ag plus, na? Okay. Here also cadmium will convert in Cd plus 2 easily. But here we are doing reverse reaction. Okay. That's why the potential is negative. So, okay. Non-spontaneous. Then you need to apply reverse potential. That's why the sign will be changed. Okay. So what you are thinking here, na? So sign will be changed. Okay. So E cell means it will be, the value will be minus here, na? It will be minus. Okay. So finally it will be okay. So this will be IR will be. So E applied. Okay, you can say, let me. E applied will be minus here. Okay, this E applied will be minus here. No, sorry. E cell will be minus here, na? So it will be minus IR. So it will be means a little bit going plus. Means you need to apply higher voltage. Okay. So finally E applied will be positive, and you need to apply more. Minus it will be okay. The negative value, more negative value will become. Okay. Clear? Is it clear? Okay, let me complete it. Okay. So this is I and this is the V. So you can see here, it should be like that. Okay. But at higher voltage, this curve is little bit deviating. Okay. And why it is so? This effect, this deviation is known as polarization. It is equal to minus 0.23 voltage. So experimental current voltage curve for operation of the cell shown in figure 2. Baseline is theoretical curve. Assume no polarization. All voltage pi. Okay, all voltage pi is the potential difference between the theoretical curve and experimental value. Okay, so what we are going to say here, that at this potential, if you draw line like that, so we can say that at this potential current should be this one. Okay, but it is occurring, this current is okay. Suppose it is 0.84. Suppose, okay, I am not scaling it much, but a little bit for understanding. 0.84 and it is 0.86. Okay, so you need to apply higher voltage to gain this current 7. Okay, theoretically it should be here only. It should be 0.84 minus 0.84. Okay, but actually you need to apply minus 0.86. Why it is due to, it is due to polarization effect. Okay, so by this way we can calculate this. Okay, then factors that influence polarization. So electrode size, shapes, composition, electrode temperature. Okay, I am not going to discuss more about this thing. Polarization, concentration and kinetic polarization. So these two phenomena are also discussed by sir. Concentration polarization and kinetic polarization. Concentration polarization I have already discussed in previous assignment section when I, okay, but we will discuss a little bit more. Okay, so in concentration polarization we discuss now why it is due to concentration difference, diffusion will be there, then electrostatic attraction, migration will be there, then convection. Okay, and convection due to external energy and whatever. Okay, so this factor will affect your concentration polarization. Okay, so this point is clear, no? Or you need to you want to explain a little bit more? Okay, only 10 minutes are remaining, so I need to little fast. Okay, so this is very beautiful picture. By this picture you can understand very nicely. This is the electrode, okay, which has negative charge, okay, and when positive ion will be attracted to our negative electrode, and when it will be you can say when it touch this electrode, it gain electron and converting neutral. Okay, see, this is the neutral ion, or you can say it is neutral ion and it has deposited. Okay, suppose it is cadmium, so this is the cadmium plus initially, okay, but now it is cadmium solid, okay, and it is deposited on metal surface. Okay, so see here only few cadmium ions are there, but as you are moving far from the this is the electrode, na? Okay, this is the electrode, it is written here. Okay, so as you are moving far from the electrode, the concentration of cadmium ion is increasing. Okay, so this is plotted in this graph. Okay, this is the distance from the electrode and this is the analyte concentration. So we are taking any concentration, there are three graphs, but let me take this graph. Okay, initially the concentration of cadmium 2 is this value, so 2, okay, whatever concentration is there, but as you are moving far from the electrode, the concentration of it is increasing, okay, but after some time it is constant. Bulk concentration, here you can say in this bulk area the concentration is almost constant, but in this region here concentration will be lowest and it will be increased like that, then it will be constant like that. Okay, simply I can draw graph here. Okay, in this area only I can draw graph, so concentration will be increased here like that. Okay, because this is the diffusion layer. Okay, after in bulk solution it will be like that, it will be constant. Okay, so this is all about how concentration polarization will be. Okay, so here pictorial diagram, a concentration showing concentration change in surface. The concentration of cadmium 2 at the surface smaller than the ion, okay, whatever it is doing here. Okay, so current potential curve for electrolysis showing the linear or ohmic region. Okay, so this region up to here is known as the ohmic region. Okay, the onset of the polarization and the limiting current plateau. This is the limiting current plateau. Okay, limiting current means your current is going limited. Okay, you are increasing voltage, but your current is you can say limiting factor now. Okay. Since the potential can be changed widely without affecting the current, now you can at this area you can increase voltage, but your current will not change. Okay. Migration you already know, so I think it not need to explain in more detail. Okay, so this is negative and this is positive, so opposite charge are getting attracted. Okay, this phenomena is very common. Okay, then in electrogravimetric analysis, how it will be work? So electrode deposition analysis, in which quantities of metal deposited may be determined by the weighing of suitable electrode for the. Okay, so it is also you can say this is grid electrode, Waldman analog. Okay, so you are applying negative voltage here, and it is this mesh, this whole mesh is known as a this whole platinum mesh is known as a electrode. Okay, it is also known as platinum gauge cathode. Okay, so it will equally means spread in all over the solution, and it will be very concentration of your energy will be uniform if you are making this type of. Okay, then test for completing of the energy. Okay, so how you will identify that your reaction is completed? Okay, so these are the some basic. Okay, it is very basic, that disappearance of color. Okay, what is the example of this? Suppose you have copper sulfate solution, so it will be blue. Okay, but when your means all copper will be deposited. Okay, so the solution color will be changed. Okay, means it will be transparent or whatever. If some other species is there, then another color, another color will be appear, but blue color will be disappear. Okay, so you can correlate this thing by reaction completion. Okay, then deposition of freshly exposed electrode surface. Deposition on freshly exposed. Okay, so by seeing electrode surface also you can say. Okay, so means it is complete or not. Then qualitative test for analyte. Okay, analyte. Okay, what analyte you are using? Okay, suppose I am using copper sulfate, but I have still doubt because some another ion is there in copper sulfate, and I am not able to identify by color only. Then what I will do? I will analyte. I will qualitative test my analyte, that is copper plus 2 ion is there in solution or not. If copper plus 2 ion is there in solution, then I will say that my electro deposition is not completed yet. I need to go for long run. Okay, so these are some things which can be understand. Two general type of electrolytic procedure are there, which are electrogravimetric without potential control, and their control potential, where we control potential. Okay, means fixed potential. Okay, then types of electrogravimetric analysis: constant current electrolysis and constant potential electrolysis. Okay, its name says constant current means you are keeping the current constant, and in potential you are keeping potential constant. Okay, these apparatus we have already discussed, so I am not going very detailed. Okay, it is already drawn and discussed previously. Okay, so it is how voltmeter and ammeter is connected in your cell. Okay, it is very also, I think magnetic stir will be provided. Okay, so it will, the purpose of this magnetic stir, that it will keep concentration of the electrolyte uniformly in the solution. Okay, so some application of electrogravimetric without potential control is analyte AG. Okay, so after deposition it will be weight as a AG. Okay, cathode, which is used for silver deposition, is made of platinum. Similarly, anode is also made for platinum, and alkaline CN solution is used. Okay, so these are some conditions which is suitable for this. Okay, so list is provided here. Okay, so for particular metal ion, what we require. Okay, so by this way you can measure electrogravimetry. Okay, it will be useful for measure unknown concentration of metal ion or some other source also. Okay, so this is the electrolytic cell. This is working electrode, auxiliary resistor, which is already discussed, I think. Okay, how we will observe voltage and all things. Okay, this is also discussed. Okay, initially when cell voltage and time, it is plot between cell potential and time. Okay, so potential will be decreased, and after some time it will be remain constant. Okay, but current initially when suppose it is copper plus 2 in analyte. Okay, if copper plus 2 concentration is sufficiently high, then current will be high. But after some time, copper plus 2 converted in copper metal, so electrolyte concentration will be decreased, so current is also decreased. Okay, and after some time it will be reached towards 0, because most of your copper plus 2 converted in copper, so that's why you are considering the decrease. Okay, so I am going to stop here only because it is already 2 hours. Okay, any doubt you can write me, or you can ask me on mail. Okay, then we will meet in next week. Okay, till then, bye bye. Okay, any doubt, or can I close the meeting? sorry. हाँ हाँ means actually working electrode means your metal is depositing on the cathode only, right? So this is working electrode means your metal is depositing on cathode. So you will measure the weight of cathode before and after depositing. So you will be able to find out that how much metal is deposited. So this is the working electrode. That's why it is known as a working electrode. But another electrode is only for complete the circuit only, no? That's why it is known as auxiliary electrode. Okay. Okay. Thank you very much for this appreciation. Okay. We will meet in next one. Bye.